Hey everyone, welcome back. In this video we'll see how can we calculate the eigenvalues and eigenvectors of a given matrix. So we'll take a very simple example and we'll solve that example, and in the procedure we'll discuss relevant theory also, right? So suppose that we have a square matrix A that is equals to 1 2 4 3, and we want to calculate two things out of this matrix. One is eigenvalues and another is eigenvectors. Okay, so first let's see how can we calculate the eigenvalues, and then we'll look how can we calculate the eigenvectors corresponding to the eigenvalues, right? So if this is the matrix, then the first thing that we need to do is find the characteristic polynomial. So the characteristic polynomial of any square matrix A will be given by the determinant of matrix A minus lambda I. And here I is the identity matrix with the order same as the matrix A. So if A is a 2 by 2 matrix, then I will also be a 2 by 2 matrix, right? So in our case, this expression here will give the determinant of 1 2 4 3 minus lambda multiplied by our identity matrix of order 2, that is 1 0 0 1. Okay, this will become the determinant of 1 minus lambda 2 4 3 minus lambda, right? And it will be nothing but lambda square minus 4 lambda plus 3 minus 8, and it will give lambda square minus 4 lambda minus 5. Okay, so this here is the characteristic polynomial of matrix A. Okay, remember, whenever you need to find a characteristic polynomial for any square matrix, you need to follow these steps. You need to calculate the determinant of A minus lambda I, and matrix I will be an identity matrix of the same order of matrix A. If the order of the matrix A is 3 by 3, then identity matrix will be of order 3 by 3, right? Now what to do? After finding out the characteristic polynomial, you need to find the roots of this characteristic polynomial. Okay, so to find the roots of this characteristic polynomial, that is lambda square minus 4 lambda minus 5, we need to equate it to 0, right? And now we need to solve it, this equation here, for the values of lambda. So on solving, lambda is equals to 5 and lambda is equals to minus 1 are the roots of our polynomial. Okay, characteristic polynomial, right? And these roots are nothing but the eigenvalues of our matrix A. So eigenvalues of matrix A will be lambda 1 equals to 5 and lambda 2 equals to minus 1. Okay, now we have the eigenvalues of our matrix A. Now how to find the eigenvectors corresponding to these eigenvalues? So we want to find the eigenvectors. Okay, so first we'll find the eigenvector corresponding to our lambda 1. So suppose v1 equals to x1 y1 is the eigenvector corresponding to lambda 1, right? And we have lambda 1 equals to 5, right? We have lambda 1 equals to here we have lambda 1 equals to 5. So we want to calculate the eigenvector corresponding to eigenvalue, that is lambda equals to 5. Remember, whenever you need to find the eigenvector corresponding to a given eigenvalue, you need to find the solution of the system of equations A minus, here we are calculating the eigenvector corresponding to lambda 1, so eigenvalue will come there. So here it will become A minus lambda 1 multiplied by I, then V1 equals to 0. So this is the equation that you need to solve. This is the system of, basically this is the system of equation that you need to solve in order to get the eigenvector corresponding to eigenvalue. Okay, so in general terms I can write it like this. It will be like you need to solve the system of equations that you will get by matrix eigenvalue multiplied by identity matrix, okay, identity matrix of the same order, then multiplied by your eigenvector and equals to 0. So you need to solve this system of equation, okay, this system of equation for this value, that is your eigenvector. So here we need to solve this system of equation for V1, okay, and the solution should be non-trivial. So what do we mean by this, that solution should be non-trivial? So if you will put V1 equals to 0 vector, okay, what will happen? LHS will become 0 and RHS is already a 0 vector. It means that the equation is satisfied. So this is a solution, but this is a trivial solution. We need to find out some non-zero V1. We need to find out some non-zero eigenvectors. That is non-trivial solution. Okay, so let's solve for our case here. I hope you are getting these things. If you already know these things, then I'll just recommend that you should practice along with me and you should solve these questions within 8 minutes, because this is the requirement that UPSC has, that you need to solve a particular question within 8 minutes. You need not to write all the steps, but you need to write the relevant and necessary steps. Okay, so let's come back to our question. Here we have matrix A as 1 2 4 3, right, and we need to solve the system of equations A minus lambda I into V1 equals to 0, and this 0 is a 0 vector. Okay, we can write it like this: 1 2, we are writing the matrix A here, 4 3, and we already know our lambda, that is 5, and there is identity matrix of same order as the order of matrix A, and here we are writing the component form of vector V1, that is x1 and y1, and we are writing the component form of our 0 vector 0. Okay, now we can further simplify it by just writing 1 minus 5 2 4 and 3 minus 5, right, and this is multiplied by our vector x1 and y1. This is the eigenvector, okay, equals to 0 and 0, right. So this can be written as, I would have skipped these steps, but I just wanted to show you how to simplify. So this is the standard technique that, like, if you will try any question related to eigenvectors and eigenvalues in the same steps, the chances to make mistakes is minimum. Okay, now many of the students get trapped in this step. They don't know how to find the non-trivial solution of system of homogeneous linear equations, right? Whenever you get such kind of step, you need to reduce this matrix into row echelon form. Okay, so I'll reduce this matrix into row echelon form. So I'll do R2 equals to R2 plus R1, and this will give me nothing but minus 4 2 0 0, and all the things will be same. Okay, and then I want to make it 1, so I'll just take the division of R1 by minus 1 by 4, and this will give me 1 and minus 1 by 2 0 0, and other things will be same. So now you can see that this whole system of equation is reduced to echelon form. Okay, now I can write this as x1 minus 1 by 2 y1 equals to 0. It means that x1 equals to 1 by 2 y1. This is again a crucial step here. So you got some relationship with x1 and y1, or maybe you have the third component also and you got two relationships like x1 is equals to something and y1 is equals to something and z1 equals to something. Okay, so you got some relationship in between the components of the eigenvectors. After that, what you need to do, you just take any one variable as some constant. Okay, let's suppose y1 is equals to t. Then what will happen to x1? X1 will be 1 by t, right? And this means, so we have taken y1 is equals to t, so x1 will be 1 by t, and this means that x1 and y1, that is nothing but our vector v1, will be equals to t, we can take common, and it will become 1 by 2 and 1. Okay, and this is the end. Okay, this is our eigenvector. Okay, so you must be thinking about this constant t here that we have taken this t here. Okay, and as per this, v1 is equals to t 1 by 2 1, and this should be our eigenvector, right? And I'm not saying that this is not an eigenvector. If we'll take t is equals to 1, we'll get our eigenvector like this, and if we'll take t is equals to 2, then our v1 will become 1 and 2, right? So you can take any t1, and corresponding to that, whatever the eigenvector you will get will be your eigenvector corresponding to your lambda 1, that is equals to 5. Okay, fine. So I hope you got a little bit clarity here, and I'll just fast forward for my eigenvector v2 corresponding to lambda 2, that is minus 1. So v2, let's suppose that v2 is equals to x2 and y2, so we need to find the non-trivial solution of a minus lambda 2 I2 multiplied by v2 equals to 0, and this is the vector 0. Okay, and this will be nothing but our matrix 1 2 4 3 minus lambda 2 is minus 1, that is minus 1 0 0 minus 1, right? And we are multiplying it by v2 equals to 0, and this will give us. Okay, now again reduce it to your echelon form, row echelon form. So On reducing it, this will give us 1 1 0 0, and this is our eigenvector. Here is our 0 vector. And now this equation, this system of equation is giving us the relationship between our x2 and y2, and this will be equivalent to write that x2 is minus y2. Now take y2 is equals to t dash, so x2 will be equals to minus t dash. So x2 y2, that is nothing but our eigenvector, can be written as t dash taken common, minus 1 and 1. And again we have got our eigenvector, that is v2 equals to t dash into t1 and 1, and we can take t dash equals to 1, so our v2 will be equals to minus 1 and 1. Okay, so let's make a conclusion here. Eigenvalues are 5 and minus 1, and corresponding eigenvectors are 1 by 2 1 corresponding to 5, and corresponding to minus 1 and 1. Okay, or by just multiplying by 2 we can write it like 1 and 2. It looks more good. Okay, so you can multiply it by any constant, or you can just try to find out different set of eigenvectors. So this is it. I hope you got the understanding about the eigenvectors and eigenvalues. If you have any doubt, you can just comment down in the comment sections, and I'll be responding to those doubts as soon as possible. Thank you for watching. Subscribe to this channel. Thank you. Bye.